Do you want to travel through time? As a common theme in science fiction, time travel can be said to be a dream for many people because he can travel back in time, correct past mistakes or regretted decisions made, and change the course of your life. So today we will talk about, in reality, is time travel really possible? In fact, from a physics perspective, time travel is not entirely impossible, but it faces many problems to achieve it. Before discussing the possibility of time travel, let's first understand the concept of time. Before the 20th century, people have always believed that time and space are independent. They have no contact with each other, and it's absolute. That is, time is a phase for everyone. And again, this is Newton's absolute view of time and space. However, by the early 20th century, there is a person completely changed our understanding of the world. He is Einstein. Einstein published his famous theory of chivalrous relativity in 1905. Chivalrous relativity tells us time and space are no longer absolute. They are seen as an indivisible whole. It is also closely related to the existence of matter, especially related to the state of motion of the object. In Einstein's special theory of relativity, it is pointed out that when an object approaches the speed of light, his time will pass by. A stationary observer is slower. That is, the faster the speed, the slower the time. This is known as the time dilation effect. Many people may ask, why does the faster the speed, the slower the time? How does speed affect time? So let's do a thought experiment. So now you're imagining that there's a box. There is a small ball in the box. The up and down vibration of the ball is 1 second. Now imagine another box. There is also a vibrating ball, but the box is moving at a constant speed. At this point, observe the path and you will find that the path of the moving ball will move in microtimes. This means that the moving ball track does a complete vibration. It requires a longer distance. It takes longer. If the speed of this ball increases, then the distance between the up and down vibration, and it will take longer. This is why it is said that the faster the speed, the reason why time slows down. Based on Einstein's special theory of relativity, the successor believes that one way to achieve time travel is to use the time dilation effect to achieve. Imagine you're riding a train, moving around the Earth at infinitely close to the speed of light. After running for a few months, it stops. Then, according to the time dilation effect, time on Earth may have passed by dozens, years, or even hundreds of years. This means that, in a sense, the people on the train are traveling to the future, although the above approach is theoretically feasible. But he had a problem, because currently we can't put any spacecraft or trains accelerated to nearly the speed of light, and reach such a high speed required energy. It also exceeds the carrying range of the prior art. Therefore, to achieve through the future, huge technical hurdles need to be overcome. In addition to speed, it can also expand time. Einstein's theory of general relativity tells us that attractive forces can also cause time to expand. In general relativity, the attractive force is a massive object caused by the curvature of space-time. The greater the rate of space-time curvature, the slower time passes. Therefore, as long as we are near a massive celestial body, near a black hole, for example, you can take a journey into the future. Compared to crossing, the future also provides us with theoretical support. But time travel back in time is more controversial because he is involved. And to many of the problems of Sister Hawaiian physics, there is time to be debated. Suppose someone goes back in time, then shoot him for himself before crossing. So how did he travel back in time? Did you shoot yourself? So there's a logical contradiction and violate the laws of the universe. So going back in time is not theoretically possible. In fact, the law of cold has already stated that time is one way, irreversible. Because within an isolated system, injuries only tend to increase. Injury is the disorder of a system. It doesn't decrease spontaneously. For example, if a cup is broken, it cannot be restored. An ice cube is heated. It can't spontaneously return to its original appearance. This is the irreversible increase in injury. So time cannot be reversed. We can never go back in time.